Hello class. In this lesson we will be completing triangle congruency proofs. So as a refresher, here are the 5 different criteria that we can use in our proofs to show that the triangles truly are congruent. So read those over and they're going to be very useful today. And here are properties that show up pretty often in triangle congruency proofs. If we have a pair of vertical angles, then we can say that the two angles are congruent, or that their measures are equal. And the reflexive property pops up whenever we have triangles that share a side or an angle. So in this first case, these two triangles share side AC, so we can say that segment AC is congruent to segment AC. And in the second example, if we look at this blue triangle here, triangle ZWU, and this green triangle, XWV, these are two triangles that share angle W. So we can use reflexive property to say that angle W is congruent to angle W. Like I said, this is a matter of taste which method you use, but for this lesson we're going to stick to the second notation using the congruent symbols. So we're going to go with the second option here. Okay, and another important property is that once you have figures congruent, all of their corresponding parts are congruent. So in today's lesson, sometimes we're going to have to find triangles that are congruent in order to get to our final step of showing that sides or angles are congruent. So these are the steps that we follow there. So you basically just have to go a step or two further than just showing triangles are congruent. You have to take that extra step and say that their corresponding parts are congruent. So here's our first example. And we always want to end with what we want to prove. So we want to prove this statement. We want to show that triangle LMN, the one on the left, is congruent to triangle LON. So what I like to do next is I like to look at my given statements. And you should write them down in your 2-column proof. And I like to mark up my diagram. You really should label it. So if we look here, they tell us that angle LNM is congruent to angle LNO. So I'm going to go over to those angles, and I'm going to draw arcs on them to show that they're congruent. So here we have a pair of angles. Okay, so when we think to the different congruence criteria we want to pick one that has to do with an angle, because we have congruent angles here. And what else do we have? We have segment MN is congruent to segment ON. Okay, so we have a side and an angle. And so we're missing a third piece here. And think about what that third piece should be to show that the triangles are congruent. So if we look back at our congruence criteria, we can't use side, side, side for this one because we have an angle and a side involved. So it's got to be side angle, or angle angle side. And it looks like based on the diagram that these share a side. So we want to, I'll just in a different color, we want to show that this side is congruent in both triangles. And how can we state that? Well, that would just be the reflexive property because Ln is congruent to itself. That's in both triangles. So that's where that's useful. So we know that we want to end our proof with side angle side. You can just write SAS and just writing out the long way so you remember what it stands for. In our first step, these statements were given to us. And so our step in between, in order to get that other side, we say that that segment is congruent to itself by the reflexive property. And remember, since these are congruent, we can also find a sequence of rigid motions that will map one triangle onto the other. So what rigid motion will get the job done here? You could reflect over line Ln. Okay, different givens, different picture, but the same basic idea. We want to prove at the very end. Now we have to think about how can we get there. Well, let's see what we're given. They give us these statements. So let's mark up our diagram. We have angle A congruent to angle D. We have segment AE congruent to segment DE. And let's go ahead and highlight those two triangles we're looking at. We're looking at triangle AEB. We want to show that this one is congruent to triangle DEC. So we want to show that the blue triangle and the red triangle are congruent. So how can we get there? We have an angle and a side, so we really shouldn't use side, side, side. And these aren't right triangles. They don't tell us anything about perpendicular, so we can't really use that. So it's got to be one of the other criteria. Well, what else can we say here? We don't have any sides in common. We don't have any angles in common. But what do you notice is going on over at vertex E? What's special about the angles there? You know that we have a pair of vertical angles. So we have angle AEB congruent to angle DEC. And the reason there's going to be vertical angles. So we want to end this with angle, side, angle. That's going to be our reasoning here. Okay, and our middle step here is exactly what we just said. Angle AEB is congruent to angle DEC, and because vertical angles are congruent. And once again, what rigid motion can we do to map AEB onto DEC? Well, we can, looks like a reflection, and we can mark up a diagram. We could draw a line of reflection in here that goes from BC through point E. Okay, there we go. So our rigid motion will be a reflection over that perpendicular bisector. So if you want to, you could also mark up your diagram here, show that you have two congruent segments there and then a right angle. Okay, here we want to show that angle AEB is congruent to angle DEC. So we're looking at these two angles. So we want to show those two are congruent. And how can we get there? Well, it's going to be our last step. And those are parts of triangles. So our reasoning should be the reasoning we talked about before, that whenever you have congruent triangles, their corresponding parts are congruent. Okay? So let's see what they give us. See if that'll help us out. They gave us that BD is congruent to CD, and that E is the midpoint of BC. So how does that help us out? Well, we know when we have a midpoint that each half of that segment, those two halves are going to be congruent. They're going to have the same length. So we got to do a little bit more work to show that. But we're going to have these two segments congruent. And it looks like we'll have these two triangles here. Lots of ways to name them. We could say triangle BED and triangle CED. Those will be congruent. And note that we don't have the angles congruent here, so we can't use that. That's what we're trying to prove. But we have DE congruent to itself by the reflexive property. So that's going to be our second to last step, showing that those two triangles are congruent. And it looks like we're going to use side, side, side for that, because we have three sides, three pairs of sides congruent. Okay, so now we have to go through the steps in the other direction to get there. So let's work with segment BC first. What can we say there since we have a midpoint? We can say that segment BE is congruent to segment CE by the definition of midpoint. So that gets us our second pair of sides. And our last pair comes from the reflexive property. You know that segment DE is congruent to itself by reflexive property. And so now, since these two triangles down here are congruent, you know that the corresponding parts are congruent. And what rigid motion can we use to map triangle BED onto CED? We just do a reflection here. Okay, in this one, we have perpendicular segments. So what should you be thinking about when you see perpendicular? You should be thinking about right angles and right triangles. So we want to show that this triangle on the left is congruent to the triangle on the right, or they're not really oriented nicely, but we have triangle ABD and triangle CDB. So that's going to be our last step. And let's see, how can we get there? Let's look at our givens. They give us all this information. And so let's see, AD perpendicular to BD, so we should think about right angle over here. So got to show that. We have segment BD perpendicular to segment BC, so we should be thinking about a right angle over there. And they also tell us that AB is congruent to CD. Those two segments are congruent. So it's looking like we should be using hypotenuse leg here. We already have a pair of hypotenuses congruent, and we have right triangles. So all we need is a pair of congruent legs. And they share this leg right here. We have BD, and that's going to be congruent to DB. Note that we have to change the order of those vertices because when we look at the correspondence, it gets flipped around. D would get mapped onto B, and B would get mapped onto D. So we want to prove this using hypotenuse leg. So to do that, we need to have right triangles. That's one of the pieces of it. And we also need congruent hypotenuses and congruent legs. So what can we say about those angles? We know that they're right angles, and that's by definition of perpendicular. And since we have right angles, we have two right triangles. By definition of a right triangle. Right triangle has a right angle in it. Okay, we have right triangles, we have congruent hypotenuses, now we just need to talk about congruent legs. And we said that we can use the reflexive property there. And there we go. And if you're a little fuzzy on when you have to flip the notation or not, you can always look back at your congruent statement. If you look at the order here, we have B is in the second position and D is in the third. But on the right-hand side, they're switched. So that's another way you can tell that you should switch the order of the vertices here. So what rigid motion will map triangle ABD onto triangle CDB? I think rotation will get the job done. Want to rotate 180 degrees around the midpoints of segment BD. So you could draw that in there. Rotate around that midpoint. In our last example, we want to show that these two segments are congruent. So we want to show that AB is congruent to CB. Let's do that one in green. So we want to show the blue segment and the green segment are congruent. So that should be our last step. And we're going to get that from corresponding parts of congruent figures are congruent because those are sides. And let's see what they give us. Let's see how that helps us. So we have segment BD bisecting angle ADC. So we should be thinking about congruent angles here because bisecting is going to cut those angles into two congruent ones. Cut that angle into two pieces, right? And they give us that angle A is congruent to angle C. And so we should be looking at the two triangles here, triangle ABD and triangle CBD. We want to show those are congruent because once we have them congruent, then we know that those corresponding sides are congruent. So our second to last step will be showing that those two triangles are congruent. Now, how can we do that? Which congruence criteria helps us? Well, we already have two angles, so we should look at our criteria and look at the ones that have two angles in them. And that gives us angle side angle and angle angle side. So we've got to decide between the two of them based on our diagram. And let's see. The included side, the side in between the angles, we can't say anything about that in these two triangles immediately because they're not in common. But what we do have in common is side BD, right? We can use reflexive property there. So we should be looking at angle, angle, side. So that's going to be our justification. So how do we get there? Well, we start off with one pair of angles congruent. We need another pair. And we said that we have angle ADB congruent to angle CDB by definition of bisect. It tells BD bisects it. And then we also need that last side because we want angle, angle, side. So we know segment BD is congruent to segment BD by reflexive property. And what rigid motion will justify this? You could do a reflection over line BD. In this lesson, we learned how to complete triangle congruency proofs. Thanks for watching this video.